as you can see, the way that formula is written there, it's going to require order of operations because they've got thrown in at us some parentheses around those two bases. So we're going to add those up first, then grab the height, then grab a half. What this half and the bases being added up really is called the median of the trapezoid, sometimes called the midline of the trapezoid. What that really is if we go and look at our parallel sides here, and then look at the lines that are between them, the other sides of the trapezoid, you find the point that's exactly halfway between the parallel lines on this side and find the point that's exactly halfway between the parallel lines on this side. Now, obviously, if we draw the trapezoid so it's not isosceles, so maybe it's something like this, right, and connect those points, you will see that sometimes it skews the line a little bit. But the way this is drawn here, all right, that midline is a line that just runs straight across the trapezoid. That half times the sum of the bases there is actually going to represent the midline of the trapezoid. And you're taking the midline and multiplying it by the height. And as you get into probably a geometry class in high school and later, they'll probably start referencing, instead of the half and the bases, they'll probably just start talking about the midline. That is the length of the midline. All right, but we'll work with what we got here. Formula says add up the bases. The bases are always the parallel sides, always. So that's my 5 and my 9, which, as you can see, I'm adding those up. I've got half I'm going to multiply that by, which again is how I generate the midline. And then the height is the one that makes the right angle with both of the bases. And as you can see, even though this one is already marked right angle, this one is not, but mathematically we've already proven back in chapter 8 that this does have to be a right angle. Realize if I extend these lines a little bit, what you've got, parallel lines being cut by a transversal, this angle corresponds to this one, so it's 90 degrees. That means this one has to be 90 degrees because these two make a line, would be supplementary. So 90 plus what's missing to make 180 has to be 90. So we've already proven that mathematically in chapter 8. We don't have to prove it again, but indeed, even though it's not marked, it would be a right angle. So it's a right angle with both of the bases. And again, the bases are considered the parallel sides. So the height here is 6. And that's where that came from. So add it up. 5 and 9 is 14. Then we can do order of operations and multiply. Half of 6 is 3. 3 times 14 changes into 42. So the trapezoid has an area of 42 inches squared. So we take a look at number 3. It says the state of Wisconsin is shaped like a trapezoid. What is the approximate area of the state? So more practice with the exact same formula, no going backwards, not messing with your head, none of that here. We're just finding the area of the trapezoid again here. So again, the formula says take the bases, which are the parallel sides, 220 and 153 in this case, and add them up. And that's what you can see here they're doing here for the bases, 220 plus 153, 373. Multiply that by a half, because half is part of the formula, and 300, which is the height that makes right angles. And as you can see, like I talked about with the triangle, it's actually drawn outside, which isn't a problem as long as it runs from base to base and makes right angles. And that's where that came from. So half of 300 is 150. 150 times 373 makes 55,950. So the trapezoid has an area of 55,950 miles squared. Notice they rounded here a little bit because the question does say approximate area, which is why in the gray box it happens to be rounded off to about 56,000. But not a big deal because they did say approximate. All right, so let's go ahead and look at the concluding examples here. Number 1, find the area of the triangle. So formula here is half times the base times the height. So I want to multiply together the base and the height, 7 and the 10, which goes together to make 70. And then I'm going to throw a half in there because that's part of the formula. Half of 70 is 35. So it's 35 square units, 35 units squared if you want to see it written a different way. Again, we're saying units squared here because they didn't say inches, feet, centimeters, or anything here. We're just saying units squared. Find the area of the trapezoid. Again, they're just trying to mess with you a little bit here because they've drawn the trapezoid such that the parallel sides are at the left and the right, which we have not seen in this note presentation today. They've always been the top and the bottom. But clearly, these here represent the parallel sides, the two sides that would never cross. Obviously, if I continued with the top and the bottom here and drew those out, those would cross out here, so it can't be those. All right, so formula says add up the parallel sides, 4 and 11, which is 15, multiply by 1/2, which is part of the formula, and then multiply that by the height, which is 6. Again, it's making a right angle, and it runs between the two parallel sides. Half of 6 is 3. 3 times 15 is 45. So the area of the trapezoid is 45 inches squared.